Let's say a few words about other services that can improve the security of your network. First of these is NAT, the Network Address Translation Service. The service appeared in response to diminishing number of public IP addresses. That's why in the IP version 4 networks, some of the following addresses are often used. From 10.0.0.0 to 10.255.255.255, single Class A network. From 172.16.0.0 to 172.31.255.255, 16 adjacent Class B networks. From 192.168.0.0 to 192.168.255.255, 256 adjacent Class C networks. These are private addresses that are not routable on the Internet. Their advantage is that you can assign them all by yourself without consulting a local IANA representative. You do not have to pay for it. However, a computer with any of the addresses from the range specified on the slide will not be able to get through to any host on the Internet. This is not entirely true. After all, we have private addresses, and yet we can connect to the Internet. The NAT service enables us to do so. It changes the addresses of the packets that pass through it. That's why the service is usually provided by the routers. We have three types of the address translation. You can see the source address translation in the picture below. As you can see, the incoming address is changed into a public address. 192.168.0.1 from the IP address field is changed into, for example, 10.10.100.100. And that's how a packet makes its way to the Internet. The response will be directed to the NAT server, which will then forward it to the corresponding computer with the private address. However, this solution is rarely used. Destination address translation allows you to connect to a computer with a private address. It can act as, for an example, a web server from the outside, from the Internet. Most often used, however, is IP version 4 address masking. The mechanism is presented in the picture below. The entire pool of addresses is changed into one public address. The NAT server has a session history. The response, which will come to one public address, will be associated with a session established by a particular private computer. The response will be sent to this particular computer. Network address translation improves security of networks. All computers are treated as one computer with a single address. This, of course, has its advantages and drawbacks. All communications between computers passes through the NAT server. It is not possible to get through to a computer with a private non-routable address from the outside. Another improvement to network security comes from proxy servers. Their working principle is very simple. They used to be used to improve the performance of certain services. When you want to connect to a remote server, you really connect to an intermediary server, a proxy server. The proxy server will forward your request on your behalf. Because a proxy server executes requests of multiple computers, there's a good chance that different computers report the same request. If the data is buffered or cached properly, the proxy server does not need to connect to a remote computer. This is the basis for optimal performance. Since all requests of that type pass through a proxy server, the server administrator is able to filter requests. They can decide, for example, that certain websites can be visited while others may not. They can also decide that executable attachments may not be downloaded from the Internet. Security-wise, it is interesting that if an attacker manages to run a proxy server and redirect your communication to the server, which is not so difficult, then he will be able to modify the requests dynamically. The attacker does not control your host or the target server, but the request, for example, to display a web page can be modified in real time and instantly forwarded. The most common way in which a request can be modified consists of attaching to a request to display a web page the request to display an invisible point on the computer controlled by the attacker. When you download data from a specific page, its entire contents are displayed. The invisible picture should also be displayed. Although you can't see it, it was most likely downloaded from the attacker's computer. In order for the picture to be downloaded, the client computer must connect to the attacker's computer. In Windows systems, establishing a connection with a remote host entails sending credentials, that is, the user authentication data. In this way, the attacker obtains users' logins and passwords. They are encrypted but usually quite easy to decipher later on. Now let's say a few words about remote access protocols and the network quarantine service. Today, when we're talking about the remote access, we usually mean VPN networks. Dial-up remote access, either through analog or dedicated connection, is no longer used. The VPN establishes a tunnel through the public connection. It's assumed that it's secure. When you use a public connection, the data you send must be encrypted and its authenticity confirmed. The PPTP, point-to-point tunneling protocol, is responsible for ensuring that. There's also another VPN protocol, the L2TP, which we'll discuss later on. Apart from the implementation details of the PPTP, two things are important from the perspective of administrators. The PPTP, which is Microsoft's original product, is not universal. It works only on Microsoft systems and within the Microsoft environment. It is also considered to be less secure than the L2TP. The PPTP used to be easier to configure, but in newer versions of Windows, both protocols are equally easy to set up. The L2TP, Layer 2 tunneling protocol, is a protocol based on PPTP. It's been modified by Cisco and Microsoft. This protocol uses encryption standards and digital signature standards instead of custom encryption protocols. It uses the IPsec. The L2TP enables the IPsec tunnel mode for the virtual network interface. That's all the protocol is required to do. It uses a TCP session for control. This created a problem for computers with private IP addresses. However, it was solved several years ago. L2TP session establishment is presented in the slide below. Please note that it requires building a tunnel between two hosts. Therefore, we have to identify the session and remote computers. A look into the Windows Network and Sharing Center will show that we have the possibility to set up new network interfaces, or new connections. Let's try to choose connection to a workplace. The VPN networks are designed for situations where the user is away from the physical location of the server that provides a certain service, an email server, file server, or network printer. Now we will try to connect to such a server. We will do this by selecting the VPN connection. To establish a VPN connection, you first need to be connected to the remote access server. We will not use the dial-up connection. We will only build a tunnel through the existing connection. This will serve us as an internet connection. This means that, in a moment, we will have two connections, both of which must be active. Both the connection to a workplace and the connection which we use to communicate with the internet must be active. The connection to the corporate network will be encrypted and signed by the PPTP or the L2TP. Let's name our connection, for example, Test. We still have to enter the username and password. In the demonstration, both the username and the password will be tested. Let's now look at the properties of our connection. For it to be established, we must, of course, choose an already existing remote access server. Let's have a look at the Security tab. When it comes to the type of VPN tunnel, we can choose between L2TP or PPTP. These are the standard options. Next, we can choose whether or not we will encrypt the data, the ways the keys will be exchanged, and the type of remote user's authentication. We will further discuss the authentication protocols in the next module devoted to remote access. Setting up a tunnel consists of creating a connection, choosing the security protocol, choosing the security level, and choosing the way to authenticate the remote user. The advantage of L2TP and IPsec is that it authenticates not only the user, but also the host. If you select PPTP, then the authentication concerns only the user. Nor will it be possible to confirm the identity of the remote computer. Now we have two network connections, each of which has a different IP address. One address will be private, and the other will be a corporate address. You may ask, which of them will be used to send data if we try to connect to a web page? This is specified by the routing rules or the routing paths set on your computer. For security reasons, the RAS servers set routing paths in such a way that the communication is forwarded by said servers. This means that you are no longer connected to the internet directly. If you want to restore the previous functionality, you have to configure routing manually.